Good afternoon, everyone. Welcome to this next series of our next topic of our series. This is a 77th series. And today, this we are, as I've been telling you earlier, we are celebrating this as a part of the Azadi Ka Amrit Mahotsav. This is a festival which is, commemorating the contribution of our people who have contributed to the growth of India. It is dedicated to people who have made a significant contribution to the country's evolution up to this point, and to those who are actively working to India Vision 2. This Azadi Ka Amrit Mahotsav is a government-initiated program that will last for 75 weeks, and now we have crossed more than 75 numbers, and we will continue till 15th August. And this will inculcate a sense of love, respect, and pride towards our country and its rich tradition and culture. It is a global movement where everyone is participating, and we at Skill Council are participating in the form of us, in the form of a webinar series, so that we can have interaction with different experts from different sectors. We are dealing with the sectors of waste, we are dealing with environment, we are dealing with sustainability, renewable energy. So these are the sectors where we are, the Skill Council is working, and we have invited experts from all over these sectors, and we have learned a lot during this process. And I think our participants have also gained a lot of information and knowledge from these interactions. So as we have completed, or this is the 77th, we have many speakers, and waste has been one of the most important or significant topic where we have had many deliberations. Today we are going to interact with a very learned speaker, Dr. Rao from IICT Hyderabad. I also had the opportunity of visiting this institute long time back, and when I was in MNRE, and I was very impressed by the developments and by the standards of the research which was being carried out there. And the topic is about it is how you will integrate waste with societal benefit, waste management with societal benefit, and sustainable development. So this is one of the areas. SDGs is the talk. In fact, it is a tagline today, our 17 SDGs. And every sector where we are working is linked to any one or two or three SDGs. In Skill Council also, we are covering almost all the SDGs, and we are working there. And we are also trying to integrate these with the areas of our work. So with this, I would welcome you, Dr. Rao. I look forward, being a microbiologist, I look forward to your, more interaction and more information on high rate biomethanation. And what I read from your, curriculum and what from your CV, that you have really, got a lot of acclaim and awards in this sector, and you are really taking it forward in a great way. And here in Skill Council, we are also trying to work. We try on waste management. We have done a lot of trainings, but we have a lot to go forward. The trainings on compressed biogas or on bio CNG, these are still to be taken forward. Maybe today we will learn more from your lecture, from your talk, and then we will ask you for more guidance. Once again, I welcome you, and I will now request Mr. PB Singh to kindly introduce you. Thank you.
Thank you, ma'am, for welcoming the speaker and audience. Thank you very much. Good afternoon, everyone. I'll welcome you all to the 77th series of the webinar. The Skill Council of Green Job is organizing a series of webinars to celebrate Azadi Ka Amrit Mahotsav as a part of India's celebration of 75 years of independence. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, and waste management, so as to be deepen in the understanding of recent development in these sectors. The first in the series was launched on 24th September 2021. Today we have Dr. Gangagni Rao, a very experienced learner and distinguished speaker who will be sharing his expertise and experience on implementation of engineering solution in the domain of waste management for sustainable development and social benefits. I would like to share his brief profile with all of you. Dr. Gangagni Rao is currently working as a chief scientist and head in the Department of Energy and Environment Engineering, CSIR-IICT. Dr. Rao completed his MTech in Process Engineering and Design from Indian Institute of Technology, Delhi. He obtained a postdoctoral degree in biofuels from University College of Cork, Ireland in 2008. Dr. Rao had extensively worked in the area of high rate biomethanation and development anaerobic gas lift reactor. He has also worked effluent and gaseous emission resulted in the development in innovative technology. He has worked indigenization of the UASB technology for waste disposal treatment of anaerobic wastewater, development and commercialization of the AGR technology, as well as the development and implementation of accelerated anaerobic composting process from laboratory to land for the conversion of organic waste into soil nutrient. A remarkable achievement is the appraisal of the working of Bonepalli biogas plant in Secunderabad in Telangana by the Honorable Prime Minister of India in his Man Ki Baat in January 2021. In his personal career is the development of about 30 biogas plants across India based on the AGR technology that he has developed and patented. His technology are widely implemented in the state of Andhra Pradesh and Telangana, and efforts are in line to promote technology deployment pan-India. He has also provided consultancy for many industrial projects, both national and international. Dr. Rao has 3 patents granted and the other 2 fields to his credit in addition to 64 research publications in Q1 and Q2 peer-reviewed scientific journals, 14 books chapters, 6 industry articles, and numerous conference proceedings, invited talks, and so on. The awards and honor have come to him all the way. The long list includes CSIR Technology Award, BRSI Industrial Medal Awards, IICT Technology Awards, DST Lockheed Martin Awards, Hindustan Door Oliver Awards, Scotch Order of Merit Awards, and Bharat Ratna Sir Yam Viswesvaraya Award. Dr. Rao also honored by a fellow by reputed academies and institutions such as Institute of Engineering India, Telangana Academy of Science, AP Academy of Science, member of Royal Society of Chemistry, London. Now I'm requesting Dr. Gangagni Rao to start the presentation. Over to you, Dr. Rao.
Yeah. Yeah. Good morning to Singh Saab, Dharmji, Madam, and others from the Skill Council of India. Really, I'm very much delighted, to give this lecture actually, because of the reason that Skill Council is like government of India nationwide. This is Azadi Amrit Mahotsav under this program they are organizing, so it will go to the many audience actually, so that no, they will be knowing about this technology. That is very interesting actually. So the outreach is very, very high actually. I am very much delighted, so that awareness can be increased. And in addition to that, so it is organized under Azadi Amrit Mahotsav 2022. So I sincerely thank all the organizers of Skill Council for green jobs, and thanks for giving this opportunity. I think I'll finish mostly in 45 minutes, something like that, and then so today my topic of presentation is implementation of engineering solutions in the domain of waste management for sustainable development and societal benefit. Next slide, please. Next slide. Slide change. I need. Yeah. See, all of you aware that no, the waste in different forms it is generated: solid form, liquid form, and gaseous form. In general, we are not like caring about this scientific disposal of this waste, because it is no one's job like that. For example, in long back, like 5-6 years back, actually, I've seen in the Amirpet area in Hyderabad, actually, people actually became very alarming, because one of the industry nearby emitted a lot of emissions. Because of that smell, no, people could not breathe properly and got suffocated. A tremendous noise is created in that area, and yesterday it came in newspaper. Then when we understood what is that actually, then one of the industries emitting actually volatile organic compounds in the form of gaseous compounds, and these are creating harm to that's why suddenly it came to more actually. That's why the people became panic. In fact, actually, most of the industrial area, if you measure this water emissions, harmful gases emissions, they are the well above the threshold limit. We did that exercise in Hyderabad, in fact, actually, and well above the threshold limit. And so very slow, like a poison, everybody is getting affected. We are nearly living in the 10 kilometers periphery of that area, who are living in that area, their health is getting affected. Because of health, so much of money we have to spend, and government of India has to spend so much of money. Individually, we have to spend so much of money actually. So that is an indirect cause. People are telling that what is the problem if the waste is not treated properly? But if the waste is not treated, so many indirect harmful effects like this actually. And for example, greenhouse gases, all of you are seeing, we are in a very alarming situation. The greenhouse gases are emitted to the atmosphere because of unscientific disposal of solid waste, etc., methane, CO2. And if they are going to the atmosphere, and how the temperature is rising, actually, in fact, actually, recently somebody started a clock, that is greenhouse emission clause actually. Maybe next 50 years, actually, the situations are very alarming actually. And I think that's why everybody has to take care. If solid waste or liquid waste is disposed to the land without any proper treatment norms, actually, it could spoil entire these water bodies, and all the aquatic life is get damaged, and all our drinking water gets damaged, groundwater also gets damaged. And ultimately, live in an environment where it is not sustainable at all. Actually, the living will be become very harmful, and people so much money, everything will be there. Without health, what we can do all these things actually? What the nation can do without the good health? So good health is the prerequisite for everybody to work hard and prosper and all these things. The country also, the nation also is very important. And in that context, actually, the treatment of liquid solid waste and disposal appropriately scientifically is very, very essential. I'll try to some of the waste we try to address, and some solutions what we have provided across India for all these type of waste like liquid, solid, and gaseous emissions. I'll try to just elaborate. It is maybe a small effort in the whole game of waste management, because in the very large quantity of waste is being generated. It is a very broader context. But what it may be a very, very small effort actually. but still it could pay way for others to implement such solutions, and so that nation will get benefit and society will get benefit, and will be in the within the reach of sustainable development goals promulgated by the United Nations actually. And government of India is also very very seriously looking at the sustainable development goals. So in this content, my lecture will go like this. Next slide, please. So earlier, what everybody was doing, it is like a linear economy. Whatever the resources are there, we are manufacturing the different products required for the mankind and compatibility of the mankind. It is a consumer society and we are consuming everything and waste is disposed. But actually, in the very recent past, actually, the new model is emerging. That is sustainable circular economy model actually, wherein waste can be reused purposefully. In fact, actually, waste from one industry will become a raw material for another industry. The whole context it is becoming. I'll tell you one simple example, very very good example actually. So earlier, all the refinery emissions, they used to let out to the atmosphere. And now, from the refinery, people are making valuable products. Place like Panipat, no, very big investment to the tune of 2,000 to 1,500 crores is being invested by the IOCL actually. And for all the emissions they're producing ethanol, etc., different valuable products actually. So such is the level of changes it's happening actually. For example, if you see plastics emanated from the society, now so much of good efforts are going plastics to fuel and plastics to variety of products like tiles, so many things, useful materials are being made actually. So like that, the model is changing from linear economy to circular economy, which is very very important for the sustainable development of the society and betterment of the society and economic development of the society in line with the environmental management. Next slide, please. So first of all, if you talk about solid waste, municipal solid waste, generally what we are doing, landfill, that is the one option, and refuse-derived fuel, mass incineration, biomethanation, biomining. These are the variety of options actually. I have seen in Delhi, if you see Gazipur, all the waste is shifted to Gazipur from the Delhi area. And it's like become like not like a waste, it's becoming a hill actually. It is like a mountain now. I have seen very, very recently. It is like a mountain. Not only in Gazipur, every city, they are making the waste mountains. These landfills are very unscientifically managed actually, and unnecessarily waste is transported from one end to another end and filling landfill. But in the cities, metros and all these things, this land cost is increasing. Availability of land is very, very important. And because of these landfills, what is actually happening actually, all the groundwater is getting contaminated and people who are living around are facing a lot of menace and all these things are happening. That's why government of India very stringently implemented scientific disposal of waste and that bargain only, even in the landfills also, refuse fuel they are making so that that RDF can be sold. And some people are doing some biomethanation and the old landfills are people are doing biomining and all these things are happening. And there is another technology has recently come up actually, maybe I think in the last 7-8 years actually, that is called mass burning or mass incineration. If you look at in Delhi, there are two plants. One is by Ramke, another is by Jindal, and approximately 20 megawatt plants are there. So all these 20 megawatt plants generating, without any segregation, this municipal solid waste could be incinerated for generating power using the gated boiler setup actually. I've seen both the plants in Ramki and Jindal actually, and they are working. Huge investments are made actually. But unfortunately, the problem with this technology is that if the gases, what are they emanated from these boilers are not scrubbed properly, it could emanate this dioxin and other toxic gases to the atmosphere. Thereby, these are all carcinogenic, and people who are living around get affected very badly. So that is the scenario, and that's why people again went to the public litigation. Some plants are partially sometimes closed again, opened, all these things, and people are not showing any further interest actually. So these are all happening actually. And in the recently in Hyderabad also, Visakhapatnam, Tirupati, Vijayawada also, 3 more plants are Jindal installed actually. These are all, if they properly operated, they are very, very good. Actually, there is no doubt about actually. But operation is very, very, very critical so that no emissions are coming from these plants. Only energy is derived actually. So that's it. In the world, like old landfill sites, people are doing biomining actually. That is also good so that this all landfills can be cleared and made it like usable land actually. Next slide, please. And in this context, what government of India has done in 2000 actually 16 actually solid waste management rules 2016 they made they told that source segregation of waste has been mandated to channelize the waste to wealth by recover, reuse and recycle, and all the biodegradable waste, organic fraction of MST should be processed, treated at disposed through either composting or biomethanation within the same premises as far as possible. They cannot let out. And this rule became very stringent in some cities. For example, you can see Bangalore. So many apartments and so many hotels, restaurants are given notices actually. And to be frank, actually, these rules some people took very seriously. For example, city like Indore, they have done excellently well. And they are doing proper segregation at each ward level, apartment level, and everything. And they are segregating, and a segregated waste is transported to different biogas plants. Now, today we have got world's largest organic fraction of MSW based CBG plant in Indore for generating approximately 18 tons of CBG. Apart from organic fraction, they are also recycling all the plastic and other waste, and they are even for the construction waste also they are processing and reusing it actually. For excellent waste management model in city they are doing it in Indore. So why only in Indore? Why can't we do it in other cities also? That is a very, very big question mark actually. So to be frank, actually, everybody has to take that model. And in other cities also like Hyderabad and some places like Chennai also, now they are very, very, very careful about this. And everybody insisting on source segregation and source treatment actually. So which is very, very important. Next slide, please. So now I'll talk about decentralized waste management. For example, if the waste is segregated, for example, you have got one restaurant, approximately let us say some 500 kg of waste is generated. What can be done in a decentralized fashion? That is the one case study I'll explain you. Next slide. So now this organic waste treatment, all of you are very much aware that so we have got this biogas technology. This is used to be called, people will call villages like gobar gas plants are there. So there are two models, a fixed dome model and a floating dome model, these biogas plants. And so many, actually I can say 12 million digesters are working in India. And some of them are also failed, abandoned, all these things, because it is very simple design. Even a machine can construct, and it is low cost also, very, very low cost we can construct. It is not well engineered. But despite the fact that intelligent people get it repaired and do it, even in fact, Ministry of New and Renewable Energy also created teams for the repairing of all these things. They are working very good programs actually. So, but there are some disadvantages like choking and all these things. There is no poor biogas quality and all these things. But the same technology cannot be used for all wastes. We need to design a proper digester for this waste. And in this context, actually, and waste characteristics plays very, very big role actually, and quantity also. These gobar gas plants are meant for 50, 100 kg, 200 kg like that for gobar. But if you want to treat 10 tons, 20 tons, 50 tons, these designs are not suitable. So in that context, what to do, we'll see. Next slide, please. So if you look at these European countries, they got very, very good technology, like it is called aerated biomethanation technology. And in fact, actually, many of the places, their segregation process is also very, very good. Segregated waste, generating biogas, the pipeline gas also they are giving. In fact, actually, most of the European countries, some trains are also running using compressed biogas. Trains are running actually, and buses are very plenty. I have seen in several places buses are running using the CBG. So and most of the places power is also being generated. for feeding into the grid and local purpose, off-grid utilization, etc. So very advanced way they are doing actually. Whereas we still 10 years back we stuck to the old classical gobar gas plants only. Next slide, please. So in this, and there are so many companies who are working in this. And for example, Compagas, Olarga, Dranko, Perth, Agronian, Bima, so many companies actually in Europe who are doing actually single patents. They are operating globally. And in fact, actually, Bima came to India and tried to enter and through UNDP program, they did something. But incidentally, it is not a very great success. Next slide, please. So if you see left side, our digesters, how they are looking actually. Can see very other right side, if you see the reactors are how modern and all these things actually. So it is very important. 10 years back we thought that 10 to 15 years back we thought that transformation of our conventional digester to modern digester is very essential in order to implement this technology very aggressively in the country, so that people will start taking. The digestion design is good, economically viable, good. It occupies space, less space. Then people will show interest and implement. So that is the interest we have to create. So that became the backbone of our research around 15 years back. Next slide, please. And if you look at conventional digester versus high rate digester, in conventional digesters, what is happening? Low volatile solids reduction, low methane yield, and hydraulic resistance is very high, and organic loading resistance is low. And whereas in high rate digesters, very low HRT, that means small volume of the digester for making higher, treating higher amounts of waste, and organic loadings are very high. High volatile solids reduction in the range of 70 to 80% and high methane yield. And for that, one more thing is also characteristics of the waste is also very important for the design. For example, poultry litter is having calcium cells, sand, grease, low CBN ratio. Whereas food waste is having very high CBN ratio. And sizes are also varying. Rapid acidification is the pH dropping. And rapid acidification is the biggest problem in food waste actually. And what are the digester design parameters? Mixing is important, temperature is important, CBN ratio is important, pH, buffering capacity, and there are 4 stages involved in the reaction, how to stage and phase it, these things, and how to maintain the concentration of solids, what concentration of solids we have to feed actually, how to remove the digested solids, and food to microorganism ratio, how to maintain. All these things are very complex metrics actually. So if you can understand this complex well and comprehends, then we can develop a high rate digester. That is the what thought process went on to our mind back home, maybe 10 to 15 years back. Next slide, please. So with that idea, we developed a self-indexed anaerobic digester having 2 compartments actually. When the reactor is fed with this waste, the gas is generated, and the gas will create turbulence in the reactor because of this bifurcation of two chambers in the reactor. We call it as a self-mixed anaerobic digester, and we have patented it in India and US and PCT countries. And based on this, next slide, please. We have installed one plant at one of the poultry station in Hyderabad actually. Next slide, please. And that plant for the treatment of 250 kg of poultry litter, we installed the plant, initial plant, and that worked very well. And and we have demonstrated that biogas can be used for many purposes. For example, in the poultry, biogas is used for also biogas guns also demonstrated. Whatever the applications of LPG were demonstrated biogas actually, and we handled and we compared the performance in terms of the conventional digester, small mixed anaerobic digester, and it found to be very good, very high. Like for example, HRT has been drastically reduced to 18 to 24 days instead of 40 to 50 days. Biogas yield improved greatly 2 times. Volume has been reduced. BS reduction improved greatly. All these things. Next slide, please. So this is the internal part, how it looked like and all these things. And we have become a competitor. In fact, actually, like a digester, like European digester we have designed. and it worked very well. That is the great challenge which we have overcome in 2007, something like that, 7, something like that. Next slide. Yeah. And after the success of that plant, we have seen some drawbacks again, and we improved the digester design very drastically, and we developed another technology called anaerobic gas lift reactor, that is the AGR technology. And again, we have patented it actually, this technology. And after what all the improvements we made, no, we incorporated and we designed approximately 1 ton of poultry litter plant in place called Thofran in Hyderabad. And after doing this, actually, we extensively studied not only poultry litter, napier grass, and market vegetable waste, food waste, press mud, and variety of substrates we studied, and different variety pre-treatment and post-treatment process also we understood, and direct reactor design also understood thoroughly. And the interesting features of these reactors are advanced digester design, smaller digester volume, easier to scale up and multiplication, semi-automatic plant operation, higher biogas yield, generation of organic fertilizer, local available enriched microbial consortia, remunerative for decentralized application, distributive biogas plant at waste generation, sir. Use of byproduct will make the plant sustainable and employment generation. With all these, so many benefits actually, so we started working this plant actually. We have developed 2 models. One is horizontal model and vertical model. Horizontal model is generally given for lower capacities in the below 700 kg, something like that. And above 700 kg or 600 kg, we are giving a vertical model. And next slide, please. And these are the models, what you can see. Patent number is also given. Next slide, please. And interestingly, when we are demonstrating this plant, no, we have tried to sell it in the poultry sector initially, but we could not get breakthrough because most of the poultry waste in India is used as a manure back to the field actually. Even though it contains pathogens, cannot be used directly like that because there are no norms in India for European countries and all Western countries, they don't use directly because pathogens are there. It cannot go to the soil like that. But in India, there are no certain norms actually. People are generally, farmers are using it, and that is being sold in the range of 500 to 1,000 rupees per ton actually. Several people are taking away. That's why they have not shown very good interest in this area. So then we have touched so many bigger kitchens. And one of the interesting Akshay Patra Foundation, which is a very good NGO, and in 2014 when we met them, no, they are operating around 10 kitchens across India for cooking midday meal to the children of school actually. So one of the place where we went is Bellary. It is in actually Karnataka. Actually, they are cooking almost 1 lakh meal every day, and they'll supply that food. They'll start the cooking at 3 o'clock, complete by 7:30, 8 o'clock. They'll pack the food and the containers, and the food packed food is supplied to schools around 50 kilometers periphery, and whatever the unutilized food they'll bring back. That is like a waste. It becomes like a waste food waste. And while preparing the meal also, they'll get a lot of vegetable waste actually. So vegetables cutting. It is a pure vegetarian food they serve actually. So approximately when 1 lakh meal is actually happening, actually prepared, we are getting approximately 1,000 kg of food waste. It consists of approximately 50% cooked food waste and 50% uncooked food waste actually. So that we have installed the plant, 1 ton plant for them actually. And in fact, actually we have guaranteed them only approximately 80 to 100 meter cube per ton of their waste based on the characteristics and our laboratory studies actually. And we installed actually, after installing actually some small process related issues we faced, we addressed all the issues. Finally, initially they are reluctant to take the gas, but ultimately after seeing the quality of gas, quality of engineering arrangements we made for utilizing the gas, because when the gas they are using, it should be utilized like a LPG only, then only they will use it. So, but biogas to use it like LPG, we need a lot of engineering modification in terms of stove and supply mechanism, everything is required. All these aspects we did, and they are very, very happy. And that is the first breakthrough what we got in 2014. And still that plant is working very, very well actually. And based on that actually, further approximately 12 plants, this Akshapatra Foundation has given us for installation, that in the range of around 500 to approximately 2 tons for waste actually. This is the first plant. The latest plant is being constructed in Varanasi, Akshapatra Foundation, Varanasi. And another is at near Faridabad, one Amma hospital is coming. Mata Amritanandmani hospital is coming, that is 1,000-bedded hospital. One more 2 tons plant is getting constructed. These are the latest actually. So far approximately we have installed 30 plants for different waste. For example, food waste, market vegetable waste, organic fraction of MSW leach, poultry litter, and cattle manure, etc. So instead of actually we guaranteed only 80 to 90 meter cube, but actually there we are getting most of the food waste plants in Akshapatra, we are getting per ton approximately 140 to 150 meter cube, replacing 55 to 60 kg of LPG. In fact, their LPG consumption almost became zero. Most of the places, all the places, LPG consumption became zero. Only food they cook using the rice husk boilers. So they will make briquetting of the rice husk, and that briquetting boiler they use for making steam. From the steam rice they will cook. But rest of the items are being cooked using LPG only. So that is the success. 2014 till now, almost 30 plants for different waste, as I told you. Next slide, please. So these are the different models where we have installed actually. Our campus, we have got one plant, and like Gujarat and Hubli and Ahmedabad, like Bellary, as I told you, and engineering colleges, so many engineering colleges, on Cap Gemini, Hyderabad campus, several plants we installed. Next slide, please. And this is one plant where we installed. There is Jawaharnagar landfill in Hyderabad. Actually, approximately every day, almost 5,000 tons of waste is being processed there. 5,000 tons, it is municipal solid waste, and approximately that is a lot of segregation they are doing, a lot of leachate is generated, and they are making RDF, they are making compost, so many plastic they are recycling, metals they are recycling, a very big processing center, waste processing center actually. There, with the help of Indo-US Science and Technology Forum help, they funded the project actually. We installed a 5-ton plant, for the 5 tons of organic fraction of MSW and 5 tons of leach, MSW leach, around 5 to 6 KL of leach we treated, and we are getting very good results. Continuously it is being operated from almost 2000, like I can say, so 15 to now, almost 6 to 7, 8 years it is completed operation. They are using the power for operating their so many equipment. So off grid they are using this power for utilization, and it is one of the best model what we have operated in this organic fraction of MSW. And the entire story was actually written by this Indo-US Science and Technology Forum in their magazine. They covering saying that one of the best innovations they have done in the recent past, like that. Next slide, please. And another plant, what we have done is very interesting plant is that. So DVT, Government of India, asked us whether this technology can be utilized for market and vegetable waste. Then we submitted a proposal for installation of the plants in Hyderabad, Telangana, and with the Association of Department of Agriculture Marketing. They have got approximately 10 market yards. In each place, approximately 500 to 10 tons range of this waste is market vegetable waste is generated actually. And first plant we installed at one of the biggest market yard, that is actually Bhovenpalli, and we installed 10 tons for the treatment of biogas plant for the 10 tons per day for market vegetable waste. There we have successfully installed this plant generating approximately 450 to 500 meter cube biogas from 10 tons of market vegetable waste, and around 100 meter cube of gas is being used in the kitchen in the same market yard for cooking food to the farmers, replacing approximately 40 kg of LPG, and balance 400 units, 400 by meter cube we are generating power, and the entire power off grid the market yard is utilizing for AC sheds, AC storage, and lights, everything, rooms, lighting, everything they are using. And approximately conventionally, off grid through grid, they are taking, let us say, 40%. Our plant is giving 60%. So 60% of their conventional electricity consumption has been reduced, and all the LPs has been reduced by our biogas intervention, this program. And next slide, please. This is another interesting plant. A lot of awards also. We got awards also. And Prime Minister of India, Honorable Narendra Modi ji, appreciated this innovation, can just play that clip, sings up. Play that. Sound is not coming? Voice, I cannot listen the voice. Voice, can you listen the voice?
Yes, sir. Yes, sir.
I'm not getting the voice. Are you listening?
रोहित वॉइस नहीं आ रहा है रोहित.
Okay, sir, I am hearing the voice. I don't know why it is not coming to you. Check first. Okay. Voice is coming from my end. I don't know why it is.
Otherwise, we can play it at the end. Otherwise, if you problem base, I'll send you the clip separately. You can play at the end if you want. Any problem? I think I cannot listen the voice anyway.
Sure. We can go ahead now, sir.
We will go ahead and you can put that clip. I'll send you again by mail. You can put it at the end again if you want. Okay?
Sure.
Yeah.
Okay, sir.
And next slide, please. Yeah. Now, see, after 10 to 15 years, what we can confidently say is that we are actually till 15 years back, we are working with conventional digesters only. But now we became very self-sufficient in terms of development of high-rate digesters. And we are competent, in fact, actually to the European countries. A digester which is looks like European digester like that we are developed with in terms of performance and aesthetic looks, space occupation, and all these things we have done actually. And generally in European countries, they are doing for higher quantities of waste. Whereas our digester is meant for even smaller. Even when we are one place in Jorhat, in Assam, we are treating only 50 kg. And as high as 10 tons per day. So that now we can do, now we are actually quoting for CBG compressed biogas plants to generate 5,000 meter cube of biogas minimum. So that is the level of range we can work in these digesters. So from down to 50 kg to, we can go to 100 tons also. That is the level of range flexibility we have developed actually to suit to the Indian conditions. Because Indian conditions are such that somewhere only 50 kg, somewhere 10 tons, somewhere 5 tons. So it should be, the technology should be very robust and adaptive. So with that only, I can confidently say we are in a very good position in terms of technology. Next slide, please. So what we are trying is that any waste comes from kitchen can be treated using this biogas technology, and whatever the biogas is generated can be go back to the chicken to replace LPG. Whatever the biomanure, you can grow vegetables, and vegetables also can come back to kitchen. So waste energy from kitchen to kitchen. That is the slogan we have under Swachh Bharat mission. We have strongly promulgated. In fact, actually, this captured the attention of so many people. Actually, next. And now future game plan is that already is happening actually. Government of India started a program called actually SATAT, Sustainable Alternative Transportation Model they have started. And in that bargain, what they want to do is that instead of CNG, they want to use compressed biogas, CBG it is called. And we are almost importing compressed natural gas, and which is costing actually almost not less than 50,000 crores per annum imports we are costing actually. So you slowly can be shifted to the from CBG from CNG, and the CBG also can be used for a variety of applications for replacing LPG, LDO, LSHS. So many fuels we can replace actually. Then country can save so much of money in terms of import this thing. And not only that, lot of waste what is available in India can be purposefully utilized. So that is the program Government of India started a very good program called Satat actually. And all in this bargain, all manufacturing companies are taking the CBG in their bunks to replace CNG. And by 2000, maybe I think something like that, 2030 or something like that, they want to put 5,000 biogas CBG plants actually. Already around 40, 35 to 40 plants are working across India, different places actually. And there are 500 entrepreneurs showed interest, and they are giving their expression of interest to these oil manufacturing companies for installation of the plant. So that is the demand, it is going very high. But for that, what we have to do from the raw biogas, we have to upgrade it to CH4. CH4 should be above 90%, and moisture content should be zero. HTS should be and less than 20 ppm. These are the some parameters for the utilization for like CNG, CBG. Next slide, please. So purification, compression, bottling are very, very important. So this is the typical composition of biogas. Next slide, please. So that is we have to make it to high standards. Highest standards are there for compressed biogas. You can just Google it and see. And one more thing is very also business perspective. Actually, biogas what fuel it replacing, that is also important. If I am generating 1 meter of biogas, 1.5 kilowatt hours of electricity, and it can replace 0.4 kg CNG and 0.4 kg LPG. The rate of sale, if you see, the value return is very high from the LPG. So if I can use this biogas for LPG replacement, I'll get more revenue. So this model also everybody has to think before deploying these plants very carefully. So that's why wherever our decentralized 30 plants, mostly as far as possible, we are giving biogas for cooking to replace LPG. So the revenue is very good. Payback is also very good. Next slide, please. So these are the variety of technologies for biogas CO2 removal and H2S removal from the biogas, so that it can be upgraded to the compressed biogas standards. Next slide, please. And this is next this flow sheet. Next slide, please. And as I told, we are doing also very good projects with GAIL India Limited, BPCL India Limited for the technology model, and I think again novel technology we are developing for this generation of compressed biogas from all these lignocellulose biowaste, agriculture waste, and different waste. And both the projects are going very well. Shortly, we'll be commercializing these two technologies which we already patented and developed actually. And now Satat program will become very active partners, technology partners. Next slide, please. So these are the assessments made by Administrative Staff College of India about technology. And one of the General Waste Management has independently written about technology, saying that is the one of the game-changing technologies in India for the waste management. Like that, they have commented. Next slide, please. So different efforts, we got coverage in the newspapers and all these things. Next slide, please. Next slide, please. Yeah, this is about the anaerobic gas lift treatment biogas generation. But some places actually what is happening, the biogas technology may not be sustainable. So we have to look for some alternatives actually. So people what they are doing composting, that is aerobic composting they are doing actually. But the issue with aerobic composting is it's giving a lot of smell actually. So that's why people started hating the technology, and so many people villages and all they're utilizing, but urban setup and all very difficult to use the technology. So and that is one reason. Secondly, some place, for example, most of these lakes in places like Bangalore, Hyderabad and all filled with water hyacinth. So when the lakes are spoiled like this, because a lot of wastewater and the sewage water is coming to the lakes without proper treatment, and due to the process of eutrophication, all these lakes getting filled with this water hyacinth, because the water hyacinth is aggressively growing there actually. So water hyacinth, it is good from the perspective of absorbing greenhouse gases, but it is very bad, and it is good from the perspective of treating the water in the lake also. But from the outside perspective, the water hyacinth is growing in that lake, fish cannot grow because of high pollution concentrations and low DO levels. And people who are living around getting a lot of smell actually because of retting of this water hyacinth during our course of period and all these things. So people look moment, like for example, Hyderabad, Greater Hyderabad Municipal Corporation spending approximately 500 to 1,000 crores for cleaning up lakes in Hyderabad. So in Bangalore, I can imagine there are 50, 60 lakes in Bangalore. So many phone calls we are getting, that so much money is being spent for this lake cleaning. Is there any alternatives? So then what we requested Greater Hyderabad Municipal Corporation, one of the lake, we asked them to give the waterizing at the shore. That is also a big mechanical process, laborious process. And at the end, we made anaerobic composting pits actually, like closed, like it like anaerobic digest only, but we will not be taking out the biogas, we'll be recycling back the biogas, so that the manure is becoming more and enriched with this carbon, and that becomes a very good nutrient soil conditioner actually. So from approximately 12,000 tons of waterizing in one lake in Kapra in Hyderabad, we made around 100 to 150 tons of soil conditioner. And one of the entrepreneur did this, invested himself money, and now he sold approximately 20 rupees a kilo. And most of the manure is 90% so far, it has been completely sold out. And we went to the recently review meeting with farmers also. We met several farmers who are using this actually. They found very, very happy. Yields are good. There is no insect problems and all these things. So several good feedback we got. So that's why we are promoting this technology also. And now government of Telangana has actually one demonstration model we have showed in place called Suryapeta in one of the market vegetable yard, like agriculture market, produce market yards will be there. So they have got around 50 in Telangana. One place we showed that whatever the market waste is coming, agriculture waste is coming in the one place, can be converted to the soil conditioner. And we installed with very 5 lakhs investment only. We installed a small plant, and 2 women are operating that plant. They are generating revenue of approximately 20,000 rupees per month. And after like whatever the operational cost, everything is there. Excluding that, they are generating 20,000 rupees per month. Both of them are earning like that. And 2 women got employment, and all the premises is clean. They are doing very well. So we have demonstrated one model last before a year. And based on that, now government of Telangana has given us to implement the similar technology for 50 places. And already some 25 places we completed. And the next 1 year we will be completing by 31st March 2024. We will be completing all the 55 we would like to operate. And all the biomanure generated, fermented organic manure generated at least will be sold bought back by one agency to sell it back to the farmers actually. So that is a very good arrangement we are making actually. And that is one of the good technology, but is very cheap and better. If the biogas people cannot afford, we can do this technology for organic waste. This is one of my recommendations. Next slide, please. So these are the different characteristics we made, and we made leaves separately and roots separately, because this waterizing, the roots contain some toxic compounds, heavy metals and all. So the roots compost can be utilized for any like for like flower purpose and all these things, horticulture. Whereas the leaves compost can be used for anything, even for food growing also. Next slide, please. So this is what we did at that lake and all different operations. Next slide, please. SCGJ, that is the company which has licensed it. Next slide, please. Next slide, please. Yeah, this is how we made that compost. Next slide, please. And you can play also. Our lake, we regenerated. After removing water, I think, we have used floating aerators. And floating aerators completely, we have one like Kodikunta Lake in Hyderabad. And what also we did at the shore, we made one composting plant, and where whenever the water is entering this, immediately they will take out and make that compost, and they will sell that compost. Like that also we made arrangements so that one composting plant, anaerobic accelerated composting plant is also available at the one of the each lakes. Like the 3 lakes we made actually. We can play that video also. Next slide, maybe. Yeah, this slide. Next slide. This is how this lake, Kudukunta Lake, it is working. Next slide, please. Next, this is the lake, how it will be pre-ascent before after that. You can see this, how this, it has been changed and all this. Next slide, please. See, another technology, what I told, this like, industrial emissions are giving a lot of malodors. and they are toxic also. And mostly these industrial emissions contains ammonia, hydrogen sulfide, amines, sulfur compounds, aromatic hydrocarbons, chlorines, volatile fatty acids, etc. No, most of the like tannery, chemical industry, bulk drug industry, polymers, all of the people know they limit this actually. We did some survey also, like ammonia, H2S, VOC, what is the range? Like not 125, tannery 80, 120. Whereas threshold limit is 25, 10.5 to 1. So see how people are badly affected actually. For example, people who are working in tannery, how approximately 100 people working on tannery, how they are badly affected actually. Most of them like India, no, Kanpur area, Calcutta area, Chennai area, so many tanneries are there. So unless we do this, no, occupational health safety hazard management, no, people cannot live healthy life. So that is very important. Next slide, please. So under CSIR program, Government of India, our Council of Scientific and National Research has given a project asking us to develop a technology. And even though there are chemical technologies and physiochemical technologies available, we have developed a biological method. Next, biological method. It is called biofilter. Next slide, please. And this is the biofilter setup. We will be biofilter will be filled with agriculture waste or something like that, very cheaper waste, like easily available waste, and we immobilize the microbial consortia, and from the bottom to top we will send the air, contaminated air, and the air is coming from the top, no. So all the absorbents are toxic compounds are degraded, and finally you will get water and CO2 only. CO2 to the atmosphere, and water will be forming in the humidity in the biofilter bedding material, which is also important for this microbial consortium. Next slide, please. So these are the different compounds which can be used in biofilter, like benzene, aldehydes, toluenes, and all these things. Next slide, please. So this is what there is a drum yard section in one tannery in Erode. So that lot of smell, H2S smell and ammonia smell, people cannot live just like that. If you enter as a foreigner enter you will feel but people who are working there, they got habituated and they're guilty. Then we installed one biofilter, 3 biofilters installed, and their water has become very, very, very minimal, and that is working for almost for the 10 years. That is biofilter is working. Next slide, please. So another biofilter installed in Fleming Laboratory C in bulk drug industry here. That is also working very well. Yes. We have taken actually coconut coir pith and all these things, very, very cheap material for bedding material, and reusable also. After that 4 or 5 years, the entire material can fill with fresh material. This can be used as again soil conditioner. Next slide, please. Another technology for the wastewater, what we have developed, bulk drug industry, most of the people are generating bulk drug industry with like high ammoniacal nitrogen and high chemical oxygen demand. So now presently bulk drug industry is doing very, very costly treatment. For example, what they will know, high TDS, high COD effluents, they do multiple effect operation and alternate thin film dryer, and then followed by reverse osmosis and so many big operational units, very highly energy consuming actually, to make it to the jet because zero liquid discharge is the order of the day in all industries. So, but all industries, some people what they will do, they will discharge this effluents to the outside. So this ammonical nitrogen is a big problem apart from COD. That is why this eutrophication, all the legs are getting spoiled because if the ammonical nitrogen is more, so eutrophication, all the weeds will grow. So COD is also very bad. So that is how these problems are happening. So that's why we developed a process called biosec process for the simultaneous removal of the ammonical nitrogen and this COD. And this is the complementary technology for the existing. For example, they're putting multiple effect operator and ATFD technology and reverse osmosis and all these things. Partially that they can replace this ATFD and multiple effect operator, put this biological system. And again, they will have reverse osmosis RO system for recycle of the water for condensate and all these things. So that type of interventions we made with one of the bulk drug industry. We closed work at SMS Pharmaceuticals, and 2 more companies actually worked. And DHT has given some funding for this project apart from this industry. And we will develop this project. Now we are trying to commercialize this for 100 meter cube per day in place called Kottavalasa near Vijayanaram in Andhra Pradesh. Next slide, please. So this is what this nitrification. Yamuna River we have seen full of foam. That is how, because of this ammonical nitrogen only. I have taken the photographs from the Yamuna River only, near Delhi. Next slide, please. And landfill leachate. All these things can be treated using this technology. Next slide, please. It is a combination of tricking aerobic and anaerobic process. This is a pilot plant what we have demonstrated to them actually, industry and DST. Next slide, please. So one more technology what we have done actually, it is integrated technology. If any colonies are available, they are generating, let us say, some amount of around 100 meter cube of sewage, and if they are generating 100 kg of solid waste, we can put actually this aerobic moving bed bioreactor, and all the wastewater very low COD wastewater. These are like sewage, no. That wastewater can be recycled for the again washing purposes or for any other bathroom purposes and all these things. Whatever the solid waste, biological waste is coming, you can carry to the biogas plant. The solid waste can be segregated solid waste can be treated biogas plant. Those things can be next. And this biogas can be given to the same, in the same colony, we can give it to some people like watchmen, all these things. Or we can put a small engine and generate power and connect also. Or nearby any small canteens, we can give line and use it. So the entire now what is happening, big STPs and solid waste management plants we are using. How to transport, why to transport so much distance, and you should wear localized decentralized fashion, we have to make treatments. So this is the one model again we demonstrate with the help of industry and the government Department of Science and Technology. Now we are promoting this, and some medical colleges in Hyderabad and area, they are showing a lot of interest actually, these two plants. Where almost next time by the time I think 1 or 2 years we'll be installing around 10 to 15 plants. These plants, a lot of demand is there because there's a lot of mandatory requirements also there. Next slide, please. So there are some few cases I have seen in the, I explained you in case of solid waste, liquid waste and gaseous emissions actually. So beyond that also some things we are doing actually for the limitation of time 1 hour and all these things. That's why I limited myself to some extent. So what I think is that there are some science solutions are available, and if you engineer it suitable to the Indian conditions that can be implemented ready-made, and our society can benefit immensely. These are all very simple solutions, small solutions, and very good, and like normal person. I'm a normal engineer basically. I'm not a great intelligent, but we could able to do it. So that means anybody can do it actually. So that can be implemented. But what we have to think is that when we are doing any solution for any problem, what is the benchmarking we have to see, and how to indigenize it for local requirements. These thought process we have to keep it in mind, and then best solution will come. Then anybody sees also that they'll compare and say that yes, this is the best solution like that. So that is how everybody has to think, and we have to promote actually. Mostly whenever I'm going to colleges and all, I'm telling youngsters. Some people also, instead of all of you going to the software and all these things, some people also should take up these green jobs. These are all not office jobs actually. These are all called green jobs. I call them green jobs. Actually, like skill council, green skill council. Very good name they kept actually. Like that, very good green jobs also available. Climate change. So many jobs are available for very good engineers and scientific people. So they should take up. I'll tell some youngsters many times like this. So that's all from my side, Singh Sabad, Madam and others actually.
Yeah.
So
now I thank you very much. It was a wonderful presentation. And the beauty of your presentation was that you have not just covered one waste, you have covered all wastes. And you have shown us all technologies which have been developed. In fact, I was remembering the Yamuna River, which gets the foams in the Yamuna River sometimes, and that ammonical nitrogen, if you say ammonical liquid waste is there, and it creates a lot of foaming, and which is very poisonous. Only what I think there's one question from Dr. Vanita Prasad before I start a dialogue with you, and I want to ask you more. Can you give the rights to Dr. Vanita Prasad? Rohit?
yeah.
Sure.
Yeah. Dr. Prasad, if you are there, Dr. Vanita? Hello? Yeah.
I gave the rights.
Yeah. Please, Dr. Vanita Prasad, she is also a name in itself in biogas technology. So
Yeah, I know her very well.
Yeah. So she has a question which she, please, Dr.
Yeah,
Prasad.
she can tell me, no problem.
Yeah. Dr. Prasad, are you there? Please unmute. You have to unmute.
Praveen madam, I sent my video clip to Singh
Yeah,
Saab. If you want,
yeah,
you can see.
yeah.
Yeah,
Yeah.
so it was great information, a lot of information and a lot of work done on the engineering aspect. So just wanted to have some tips how we can able to really work on field for these plants. That's what I actually want to understand, because I was in the other meeting with ma'am where some of the plant operators mentioned
Yes. Yes.
gap for
It's good you brought out this point. You know, I also wanted to ask him the same things, that during the trainings we had a lot of questions. Yeah, please carry on. Yeah.
Yeah, so that was the part actually, a lot of actual data from the field. If we can get it and we really can solve those issues, will help this sector to grow, because a lot of things has been done on engineering side. Once I will say hand in hand with the microbiology side or the biotechnology side, this will make a wonder. This will make a wonder, and in next 3 to 4 years, we might be having energy surplus, because a lot of Satat plants are about to come. So, sir, please.
Yeah, there are two aspects for feed actually. Yes, if you are talking about organic fraction of MSW, as I told you, segregation is a big issue. I'm telling you, in Hyderabad, we are generating 5,000 tons of organic fraction of MSW. And we are operating 4 plants, each, 3 plants with 500 kg capacity, 2 plants with 10 tons capacity we are operating. And we are finding it sometimes difficult to get feed, because the segregation is a big issue. Yes. So, in fact, I'm spending time, a lot of time in talking to that person's market secretaries and all the guys. So, make segregation methods, educate them like that. We are doing so much of groundwork actually. Even then, it is becoming very tough for me. So, it is a big, actually, I'm telling you, it is a big painful for the persons who are giving technology, putting plant, and the plants are not being operated because of lack of feed. It is a big problem. And another thing is that, one more issue I found. For example, we touched several restaurants, big star hotels in Hyderabad, who are generating around 2 tons, 3 tons, 4 tons food waste, very good waste for biogas generation. I also given them offer saying that, no, we will invest, put the plant, sell the biogas to you. For example, your LPG is 100 rupees kg, give us only 80 rupees for us. And we'll keep on take the biogas. Manure also will take it back and dispose it as per our convenience. Or we'll sell it. You give the waste, some space, and use the biogas. That model is also not doing. What they are telling, sir, some people are coming, these dairy people, these piggery people, and they are taking all the waste, sir. We are not wasting, having not any waste like that. But the truth is something different. That is not there. In the nights and all, they are dumping in some rivers, canals, and all these things. And when the pollution control becomes stringent, no, everybody purchased these composters, high costly composters, high energy consumption. They kept like a showpiece in front of their hotels. Never they operated those composters. If they purchased, if they are operating, okay, I'll be happy, but they never operated those composters. So this mindset of the people has to be changed very drastically. See, Swachh Bharat Abhiyan, a lot of changes have happened. Still, our mindset has to be changed. That is about this sector, general societal sector. But for us, agriculture waste and other waste, like press mud, agriculture waste, napier, these are all like organized sectors. That is, feed is not a problem. For example, any commercial plant, Satat program is coming, when the feed is able, then only that person will install the plant. Punjab or whatever, for example, we are now processing 5 clients. All of them have got very good feed. Press mud, they are having very good, approximately some 200 tons. One person is growing in 100 acres napier grass. Another person is having actually approximately every day 40 tons to 50 tons of rice husk, like that. So those are organized sectors, there is no problem. But unorganized sectors, still the segregation is a problem. And MSW solid waste management 2016 should be promulgated very seriously. And in fact, actually, Indore, as I told you, case study, that is the one city which they have done excellently well. And see, at plus point, I can say recently Tata Consulting Engineering has prepared a report based on the request of GIZ and the Ministry of Urban Development, Government of India. But they are saying that all these things, society-based biogas plants are 90%, 80% not working because of some reason or other. But most of the plants, this feed is not available. So that is the report they have given. Actually, Madam also knows actually. Praveen Madam also may be knowing about that report actually. Recently, I attended a meeting actually in some hotel in Delhi. That is the state of affairs.
Yeah, yeah.
Because technology is on part, separately waste making available plant is becoming very, very critical actually. That is everybody listening. So this further, this urban local bodies further, they have to gear up, do this activity sincerely, because everybody thinking what will happen if the waste is disposed like that. They think, but they are not, nobody thinking about long-term effects. When we let plague and all, no, 20 years back in Surat, they let plague and all these games, and suddenly people get alerted and after that they'll forget. So that is unfortunate. Vanita Madam, actually, even Praveen Madam also, I would like to tell that.
Praveena ma'am, we actually have to look into this matter. That's what we were talking. So as experts in this sector, we really have to look into this matter and try to sort it out as early as possible. So ma'am, you please take it up as we discussed. If we can get this list of plants which has been put up and still not working, maybe because of feed, maybe because of another issues, we can handle it, try and revive these plants.
You send me a mail, please. I forgot.
Yeah, so that's what actually I was asking you. If you can send me some list, I can contact them.
I will compile and send to you.
Yeah, sir, I will be in touch with both of you. I had another meeting, so I will be leaving now.
Yeah, please.
Thank you very much. I will be in touch with both of you to make this sector really grow.
Yes. My question to you is, Dr. Rao, you had shown so much technologies for the liquid waste coming from the industrial waters, the waste coming and reducing the COD and reducing the ammonia. So have you brought this technology to the notice of the Central Pollution Control Board? Because, we have done so many trainings in the CTPs in Delhi. And there we found training the workers was very good. The technicians was very good. We could formally, tell them about the projects which they were doing or the material which they were handling. But at the end of it, the process itself should be, it should be made better. The process, if you see, I think the CTPs, when we went and visited or when we had the trainings, that is the time they put them into motion. Otherwise, they must be closed. So have you been in touch with the Central Pollution Control Board?
No, madam, but local pollution control boards, I'm interacting with them, like Telangana and Andhra Pradesh. I'm keeping.
So do they honor the technologies which you have developed?
Yeah, they are recommending it to the people. Industry is also very, very actively participating. We're trying to see some break-even is required, madam. Any technology, First one person has to take, then only others will take. Like I told 2014, one biogas plant, no takers were there. So one Akshayavatra Foundation took it and they demonstrated, they felt happy, and that is how replications happened actually. So first one, ice breaking is required. That is we are trying, madam. We'll try our level best. And as I told you, I'll send mail to this CPCB people also. I'm in touch with this regional CPCB Chennai. So I'll also contact them actually.
Yeah. No, but you must be having those CTPs, those industrial effluent treatment plants. So likewise, we had organized trainings in Delhi. The technicians were very much benefited out of it. In fact, it was the first classroom training they had ever had since they had joined jobs. So if you are in touch with them, you can direct them to us. We have got training modules where we would like to give them.
Sure, madam. Sure, I'll definitely do it.
That is one aspect of it, because CPCB is not very receptive. See, there were algal technologies or biological treatment, some of the plants, effluent treatment plants wanted to put up. But they said that, you'll have to take all the approvals, all the permissions again. So that is very difficult. If you take up some technology and then again you have to go to the rut of setting up though NERI has said that we will review the plants, whatever they have set up, and the Ministry of Environment and Forest, and they will see what upgradations can be made. But if your inputs go to NERI or if they go to CPCB, maybe it can always help. GIZ, you said GIZ also is monitoring these plants, and there was some report also, which I attended those workshops, where they, whether they want to continue the monitoring and the operations, wherever role they have in these plants. So I feel your contribution, apart from what you are doing in the biomethanation is very good. You can connect with all the 5,000, the investors who are doing this, and they will be very happy. In fact, I had an investor 3 days. He had come to me looking for a technologist. Imagine, he has the money, he has the land, and he was looking for a technologist for Napier grass, technology. So this is the condition, under Satat, LOIs have been issued, but people have not connected properly with the technologists. So that connect has to be made. Yeah.
Correct. Yes.
Yeah.
Yes.
So I think the overall, the presentation was very good. And of course, the recognition you got from Honorable Prime Minister, that was also worth mentioning, and it is a right approach what he has projected. He has not picked it up just for the sake of picking. It is something which can contribute as a decentralized solution. So that is why it has been picked up. So thank you very much. And
Ma'am, 1 minute.
Yes.
Mr. Rakesh Bhan wants to say something.
Yes.
Yeah,
Please.
on the chat. Rohit, can you?
Can you give him talking rights? Yeah.
I give the rights.
Yeah, please. I didn't. Sorry, I missed it. Yeah.
Yeah. No, ma'am. No issues. Rakesh Bhan. Mr. Rakesh Bhan, can you ask your question?
If you have any question, kindly unmute yourself and ask. I think sir is not there.
Dr. Rao, good afternoon.
Yeah. Tell me, sir.
We have seen technologies from kitchen, home kitchen to the kitchen. But I wanted to know, has this technology been commercialized in any place in India? Whether the technology has been proved and the technology is commercialized? And if so,
yes, sir. Actually,
which organization have commercialized the kitchen waste to kitchen LPG?
You can scout Akshay Patra Foundation, sir. Akshay Patra Foundation. We installed approximately 12 to 14 plants. You can see, for near to you, if you are in Delhi, there is a Sri Krishna birthplace is there, sir. Vrindavan. There is one plant is working there. And shortly, one plant is coming in Hyderabad near Mata Amrit Hospital, 2 tons per day plant. And there are 15 plants working across India, sir. You can Google Akshay Patra Foundation. You can call nearby place, they'll show you. If you can come to Hyderabad, I will show you. No problem. Here also, 5 plants are working.
Okay. Any other questions from audience?
I don't think so. But
clip, I will send you email clip that if you want to play, you can play now.
Yeah. Rohit, can you do?
Yeah.
Sure.
You can put his mail, and if you can, connect with all of them. Yeah. Whosoever wants any information. So I think Dr. Santosh is also there. What is this?
No, not that. I separately just now I sent one small clip attachment I sent.
Mr. Santosh, would you like to ask any question? Yeah, Mr. Santosh, welcome. Yeah.
I know Dr. Gangagni.
Yeah, everybody knows everyone.
Yeah. Basically, we are exploring options to convert rice straw to biogas.
Fantastic. Good, sir. Very good.
Yeah. Have you done any experiments on using
yes,
biomass like rice straw?
Yes, sir. We did rice husk and rice straw both.
And are you connected with one of the Satat program for rice straw anywhere in Andhra, Tamil Nadu?
No, Satat program, no, sir. But we are doing project with BPCL now. We have completed this rice straw and rice husk. And now
Okay.
they are looking for some investors to install the plant, and we are negotiating. Next week we have some meetings.
You are doing it with which company? I didn't get it.
BPCL.
BPCL. But
Yeah.
HPCL is doing it in Badaयूं. They have already set up a plant on rice straw. And in fact, now we are doing the trainings for aggregation from this month onwards. We will be training the farmers in the aggregation of this agro residues, and of course, biomass depot operators also, so that they can store it properly.
Yeah. People are there. There are plants. There are around 4 to 5 plants on agriculture waste.
Yeah. So
there.
BPCL has no problem getting the rice straw?
Most of the places they have got arrangements with these feed arrangements, madam. There is no problem.
Okay, with
Punjab, one of the biggest plant on agriculture waste is working 32 tons of.
Yes, sir. Rao sir, one specific thing happens. There are technologies, but these rice straw and these projects need to be absolutely economically viable cases. In MSW food waste, there it can be subsidized somewhat because it's a different ballgame. For urban area, they have to manage waste. But when we go for rice straw based CBG, then the thing has to be economically viable, because then only investors would invest in the project. And it has become very difficult for us to prove that it is economically viable. Have you, the thing that you are working with, is it a bankable thing or?
Bankable solution, sir. Offline you can connect with me. You can write down my number. You can take numbers from my numbers from Singsa, PB Singsa, and you can call me and explain you different details. You can have a discussion, I think, sir.
Okay. Yeah.
I think the numbers are displayed here.
Either numbers are here. You can take the numbers, sir. My numbers are here.
You can. It's not in the chat box, Rohit. This should be in the. You can put it in the chat box.
Okay, madam. Can we finish it off?
Yeah. Thank you. Thank you very much. I'll just. It was a wonderful presentation, and I'll just ask Mr. PB Singh to formally thank you. Thank you very much, and thank you all.
Thank you, madam.
Thank you. Can I run the video or we are over?
Yeah, please.
Please run.
Sure.
Okay.
Is this audible?
No.
Yeah.
Okay.
So PB Singh, we can't hear you.
Yeah, ma'am. Hello.
Yes.
No issue with that. I know the.
Is this not audible, sir?
No, not audible. आवाज आ रहा है?
Your one email is also received for.
कुछ दिखाई नहीं दे रहा, रोहित.
So I will align the same and.
Mr. PB Singh, please contact the.
Okay.
I will align the same on Monday.
I don't know why it is not audible, because it is audible from my end, sir.
I can listen to you.
Yes.
रोहित, ये स्क्रीन हटा दो यहाँ से. Files जो खोला है. Okay. Anyway, thank you very much, sir, for the excellent presentation. Sir, you explain in very well and very details. Hope all the audience get knowledge and benefited with this presentation. Once again, thank you very much, sir, for very informative presentation. Thank you, sir. I would like to thank all the participants for his valuable time. Thank you all. Thank you very much.
Thank you.
Thank you, sir. Bye-bye.
Thank you, sir.
Thank you.